all other fields which I have discussed just now. Okay, now I'm coming out of this particular PPT because already I have discussed. And here it says whatever the level of application you are going to have, the more important thing is the challengeable technology is the synthesis of the nanomaterials. How you are going to synthesize these nanomaterials? Okay, and you can see that already just now I had a discussion. It has shown it is a tremendous application everywhere in opticals, electrical, magnetic, catalytic, biomedical properties, and some high surface volume ratio. Okay, due to all these, it has and it is not so pollutant, and we can be mixed with the organic and inorganic based systems, and it can be made more suitable for certain applications. Okay, and now the history of nanotechnology traces the development in the concept and the experimental work falling under broad categories of nanotechnology. Okay, so here the actually the very important thing is that please try to remember how you are going to synthesize the nanomaterials. How you are going to synthesize the nanomaterials. This is one of the challenge which we have to discuss more about, and it is a certain level, if we can say, it is to the scientific level now still. Okay, usage has come down to everywhere, but in a scientific level, we have to do a lot of research work for particular applications. Okay, and this nanometer, just in the beginning I was talking about, in the 9th century only this nanometer was started used in the for some other applications like the modern technology. The people, they started making the colored statues and all. They do the color artwork. So this color artwork and all these will be colors will be extracted from the greeneries, from the plants they used to extract. So to preserve this, what happens? They used to make a lamination of a transparent cover, which can preserve for the long time, even from the Egyptian also. So in such situations, the transparent nano level metallic film will be made, and it will be lapped over this, glazed over this. So which may contains the copper and some of the silver particles in the nano level, and it will be transparent enough. And you can find another one, the nano shirt, in the recent days, the nano shirt, and which will not allow the water to get inside. It will not allow the dust or some other particles to be fallen on that. Always it will be fresh enough. A nano shirt, just around, I think around 6 to 7 years back, one of the companies, they started using making the nano. They even need not watch it. Always it can be in our body, and always it will be not attracting any kind of dust particles or any water or anything else. It will be fresh enough. Okay, such kind of things also can be done. Now, these are all the wonderful applications and the preparation, how and what are the the different ways by which we can able to prepare the nanomaterials. And the nanomaterial is, please do not feel wonder, it is the nanomaterial. Maybe if you are having the silver particles, we are going to break down and we are going to grind it up to the level of nano, and it will be a nanomaterial only, nano powder. So nano powder, you can just a very simple example, your the Colgate tooth powder, or your the some of the lotions. Okay, those will be up to the nano level. So those kind of things can be called as nanomaterials, and the nanomaterials may be ceramic or metallic or non-metallic materials. Okay, those can be used. And another one, these individual particles will be having the different characters. These different, for example, I am going to prepare a nanomaterial for the copper. The copper particle which you are going to talk about, the individual one particle of nano level copper material, and which behavior it will be slightly different. And once you are going to construct or synthesize into a nano composite material, that time its behavior it will be different at different or elevated temperature. When you are going to mix with some other base materials, the behavior it will be different. So it is very, very difficult to understand by looking into some of the properties, mechanical properties, but one has to go to the depth of a nano level and think about what changes have been happened with respect to the required input controlled or uncontrolled parameters. Okay. So there are two approaches. By these, we can able to synthesize the nanomaterials, or we can able to fabricate the nanomaterials. So basic approach is for the fabrication of nanomaterials, or the preparation of nanomaterials, or a synthesis of nanomaterials. Okay, nanomaterials. So there are two methods: top-down approach and bottom-up approach. Top-down approach and bottom-up approach. A very simple way I'll be telling you. Top-down approach. I have been given one ceramic material. The ceramic material, what I'm going to do, I'm going to make into a small slabs, again crush it and go to the next level and next level like that. Finally, I'm going to get the nano particles of the ceramic. This is the top-down approach. The top-down approach is we are going to break down the given particle step by steps to get the nanomaterial. And bottom-up approach is one. Here already the nano level particles are available with the material itself. These individual nano materials which are available with the material itself, that will be rearranged in its time. That will be called bottom-up approach. Please try to remember, try to understand. The top-down approach is one. Please make a note of it also. It is very, very important. Explain the basic method or synthesis by means of a top-down approach, and explain the fabrication of nano structure by using the bottom-up approach. Like that, the questions may be. The top-down approach is given material will be broken into a smaller size particle step by step to get the nano material. That is the top-down approach. Bottom-up approach is that already the nano, up to the nano scale, the material is to be available. What happens is the copper, for example, its items are there. And I cannot call it as a copper nanomaterial. The nanomaterial, which is one we require to synthesize it and to get a behaviority of nano composite material, the atoms or the molecules have to be rearranged within it. That will be bottom-up approach. Okay, these are the two approaches we need to go through. Okay, and try to understand or remember the very important topic whatever discussed today. Explain in briefly the different applications or applications of nanomaterials for in the various fields, and explain the application of nanomaterials in the fuel cells or nuclear reactors, or for the electricity, for the filtration, for the aviation, for the aerospace industries, and some other specific applications we can able to discuss. Then even includes the biomedical applications also. Okay, next is the two basic approaches, are the basic approach of preparation or synthesis or fabrication. Synthesis is also same, preparation of the composite material also same, or fabrication of nanostructure also same, or the preparation also same. So there are two methods by which we can have the preparation or structure, the preparation of the nanostructure. One is top-down approach and bottom-up approach. Top-down approach, it is not having its nanomaterials. What happens? We are going to break down into smaller particles, step by step, so that finally we will be having the nanoparticles. There will be a ball mill or some kind of mills will be there. So these mills, they will be having the container. In this container, the powder is filled inside, and there will be hardened steel balls. And once you rotate at very high speed, what happens? Due to collision of these hardened steel balls within the container, what happens? This particular aluminum copper or a mild steel or XYZ ceramic, whatever it is, that will be broken into smaller particles, and at a particular speed and the weight of the steel balls, we can get the standard nanoparticles for the archer. And even we can get it from the post also. Bombay, so many people are there. They are preparing the nanoparticles. So those will be taken into a small container, and based on the requirement, we are going to refabricate it. Okay. And bottom up approach is one, already the material will be having its own the nano scale of items will be there, elements will be there. One of the thing is that what you need to do, we have to rearrange them in a required pattern so that it can be called as nano structure.